Okay, so hello and welcome back. So the next question that we have is question number 9, which is let star be a binary operation on the set Q of rational numbers as follows. So let star be a binary operation on the set Q of rational numbers as follows. So part 1 of this question is A star B is equal to A minus B. Part 2 of this question is A star B is equal to A squared plus B squared. Part 3 of this question is A star B is equal to A plus A times B. Part 4 of this question is A star B is equal to A minus B whole squared. And part 5 of this question is A star B is equal to AB divided by 4. And part 6 of this question is A star B is equal to AB squared. Now, for which of the binary operations are you want to find which of the binary operations are commutative and which are associative. Are commutative and which are associative. So to answer this question, so you have basically star defined on the set Q, right? So the set Q is the set of rational numbers. The set of rational numbers is basically Q is basically the set of all basically A divided by B, for example, or you could say P divided by Q, or you could say P divided by Q, such that P and Q belong to the set of integers, and Q is not equal to 0. Meaning that any number that can be expressed as the ratio of two integers in such a way that Q is in such a way that your denominator is not 0, then that number can be called a rational number. So now part 1 of this question is basically A star B is equal to A minus B. Now, as you can see, of course, subtraction is not commutative, meaning that, for example, if you write, suppose that you have two numbers in the set of rational numbers. For example, suppose that you have 1/2 and 1/3. So in that case, basically 1/2 minus 1/3 is going to be equal to 3 minus 2, which is equal to 1/6, and also 1/3 minus 1/2 is the same thing as 6, 2 minus 3, which is equal to negative 1/6. which means that A star B, is not equal to B star A, and therefore star is not commutative. Also, if I take three numbers in the set of rational numbers, for example 1/5, 1/2, and 1/3, if I can show that basically A star B star C is the same thing as A star B star C for all A, B, and C belonging to the set of rational numbers, then that means that then star is star is associative, which is of course not the case here, because if I go for example these three numbers, and if I write basically, if I calculate A star B star C, that would be equal to 1/5 star, for example 1/2 star 1/3, which is the same thing as, and over here we are saying that A star B is equal to A minus B, and here we have A star B is equal to A minus B, and therefore this becomes 1/5 star 1/2 minus 1/3, which is equal to 1/5 star, and 1/2 minus 1/3 is equal to 1/2 minus 1/3 is equal to 6. 3 minus 2, which is equal to 1/6, and that is equal to 30. That's a 6 minus 5, which is equal to 1/30. Now if I calculate A star B star C, that would be the same thing as 1/5 star 1/2 star 1/3, which is the same thing as 1/5 minus 1/2 star 1/3. Now 1/5 minus 1/2 is the same thing as 10 to 5, so -3/10. So that's the same thing as -3/10 star 1/3, and that is equal to -3/10 minus 1/3, which is equal to 30. 30 divided by 10 is equal to 3, so that's -9 minus 10, so that's -19/30. So as you can see, A star B star C is not the same thing as A star B star C. Therefore star is not associative. Therefore, star is not associative. Okay, so basically part 2 of this question. The question is asking basically, now we have star is a binary operation on the set Q and of rational numbers, and basically we have A star B is equal to A squared plus B squared. We want to know whether star is commutative or also associative. So if A star B is equal to, if star is a binary operation defined on the set of rational numbers, and if A star B is equal to A squared plus B squared, then what we have here is that now commutative means that A star B is equal to B star A, which means that basically you have A star B is equal to A squared plus B squared, and B star A is equal to B squared plus A squared. So when you add when you add two rational numbers together, so basically if A is a rational number, now since A and B belong to the set of rational numbers, then A squared and B squared also belong to the set of rational numbers. Now in Q, basically in Q, when you add two rational numbers, when you add two numbers, basically when you add two numbers, the order does not matter. The order does not matter. Therefore, basically A squared plus B squared is equal to B squared plus A squared, which implies that A star B is equal to B star A for all A and B belonging to the set of rational numbers. Therefore A and B are therefore basically star is commutative. Right, so now let me take a look at the argument that they have. And so basically we have the same argument that we have provided here. And if you want to know basically that star is associative, so we have again the same story, meaning that basically A star B star C is basically based on this rule. We have A squared plus B squared star C, which is the same thing as A squared plus B squared plus C squared. So we have a squared plus b squared, so that we take this whole thing as a squared, for example, and this whole thing as and this c as b squared, for example, as b, for example, and then this becomes a squared plus b squared plus c squared, which is the same thing as a squared plus b squared plus c squared. And moreover, a star b star c, and moreover a star b star c is the same thing as a star b squared plus c squared, a star b squared plus c squared, which is the same thing as a squared plus b squared plus c squared, which is the same thing as a squared plus b squared plus c squared. Which means that, and as you can see, therefore a star b star c is the same thing as a star b star c for all a, b, and c belonging to the set of rational numbers, and therefore star is associative. Therefore star is associative. So that is the second part of this question. The third part of this question is a star b is equal to a times a plus ab. A star b is equal to a plus ab. And also we know that star is a binary operation defined on Q. Is a binary operation defined on Q. Now what we have here is that basically a star b, that is a star. So what we have here is that a star b is equal to for commutative, a star b is equal to a star b is equal to a plus a times b, right? And b star a would be equal to b plus b times a, which is equal to b plus ab. So as you can see, a star b is not equal to b star a. Therefore a star b is not equal to b star a. And therefore star is not commutative. And therefore star is not commutative. And then about being associative, you can say that basically a star b star c, for example, a star b star c is the same thing as a star. Now b star c would be b plus b times c, and a star b plus b times c would be equal to basically the first number that you have here, which is a, which is A, plus the first number times the second number, which is basically A times this whole expression. A times this whole expression, which is B plus B times C, which is equal to A plus AB plus ABC. Right, so that is basically A star B star C. Now B A star B star C is the same thing as A star B. We said that it's equal to A plus AB, and that star C, and that's the same thing as the first number that we have, which is A plus AB, added to basically the product of the first and the second number. So C times A plus AB. C times A plus AB, which is the same thing as A plus AB plus AC plus ABC. So here you have AB plus AC plus ABC plus A, and here you have A plus AB plus ABC. And as you can see, of course, A star B star C is not equal to A star B star C, and therefore star is not associative. Star is not associative. Now there is one thing here that of course there is one thing that could be true, meaning that under some circumstances it's possible. I'm not sure that if it's at all possible, but it is possible that under certain circumstances, for certain values of A, B, and C, these two expressions might give you the exact same results. That's well possible. Meaning that if you keep looking for the right values of A, B, and C, and then put them in these two expressions, you might actually get the exact same results. But it's not easy to find such numbers, and in such situations, in order to make sure that basically that star is definitely not associative, it's enough to provide one counter example. And so, for example, for one counter example, you can take, for example, three values for let me see where I was here. A plus A times B, right? So that was part 3. And so, for example, if you take three values here, for example, like 1, 2, and 3, and if you show that for these three values, at least for these three values of A, B, and C, A star B star C is not equal to A star B star C, then that means that star is not associative. So meaning that you cannot be absolutely sure that that these two expressions are going to be different for all the possible different values of A, B, and C. There might be some values of A, B, and C for which basically these two expressions are even that these two expressions will even give you the exact same result. But that definitely doesn't happen for every possible value of A, B, and C that you pick here. And so in order to just simply show that this is not associative, you can just simply show that this is true for example, one instance of the values that you could pick for A, B, and C, for example, 1, 2, and 3, and then that way you can prove that basically star is not associative. So so that is that basically. Now the next part of this question is part 4 of this question. So we said that star is a binary operation defined on Q, and basically here star A star B is defined as A minus B whole squared. Now, in order to show that that star is commutative, you can calculate A star B. So A star B is the same thing as A minus B whole squared, which is basically, this is the difference of two rational numbers, and then when you raise that difference to the second power, you're going to get some positive number. And if you calculate B star A, you are going to get, for example, B minus A whole squared, and this is the difference of the same two basically rational numbers, but written in the reverse order, and then you are raising that number to the second power, meaning that again you are going to end up with a positive number. And so you can conclude that A star B is actually equal to B star A for all possible values of AB belonging to the set of basically rational numbers. Because, for example, let's say that I take, for example, the value, I don't know, 2 and 3, for example, right? So 2 star 3 is going to give me basically 2 minus 3 whole squared, which is equal to negative 1 squared, which is equal to 1. 3 star 2 is going to give me 3 minus 2 whole squared, which is equal to 1 squared, which is equal to 1. And any other value that you pick from the set of rational numbers, the same thing is going to happen, because always A minus B whole squared is going to be equal to B minus A whole squared. That's basically always the case. Except for, well, at least I can say for all the numbers that you can find in the set of rational numbers, that is the case, right? Or you can prove it this way, meaning that the way that you can prove it is that basically you can say that you can this is another good way to say the same thing, meaning that for A and B belonging to, you can say that for A and B belonging to the set of rational numbers, we have basically A star B. We have A star B is equal to A minus B raised to the second power, and B star A is the same thing as B minus A raised to the second power. So I can write basically I can write this as negative of A minus B, negative of A minus B raised to the second power, right? So I can write basically, instead of B minus A, I write A minus B and raise the whole thing to the second power. So that's the same expression. Which is the same thing as A minus B raised to the second power. and thus A star B is equal to B star A. That is the right way of basically talking about this. Thus the operation star is commutative. Thus the operation star is commutative. And for being associative, you can say that basically you can create a counterexample here. You can create a counterexample here. Here basically we said that A star B is equal to A minus B whole squared. A star B is equal to A minus B whole squared. So if I pick a couple of values for, now let's take a look at the expression here. So A star B star C would be the same thing as A minus B whole squared star C, which is the same thing as A minus B whole squared. So you have basically this whole expression minus this expression raised to the second power. So that's A minus B raised to the second power minus C raised to the second power. This is A star B star C. Now if I calculate A star B star C, that gives me A star. Now B star C would be B minus C whole squared. Now B minus C whole squared, now A star B minus C whole squared is equal to A minus, A minus B minus C whole squared, right? Now of course if I call this 1 and if I call this 2, you can easily see that these are not the same things, because 1 is going to give me basically A squared plus B squared, minus 2 times AB and minus C. That is going to be the value of and of course raise the whole thing to the second power. And 2 is going to give you basically A minus B squared plus C squared minus 2 times BC, and raise the whole thing to the second power, which is the same thing as A minus B squared minus C squared plus 2 times BC to the second power. And of course you can see that well, these are not the same things, at least not for all the values that you could find for A, B and C. Now in order to make sure that what you're saying is correct, you can say that for example 1 star 2 star 3, take for example for A, B and C, take 3 values as 1, 2 and 3. And now you can calculate for example 1 star 2 star 3 is equal to basically so we said that A star B is equal to A minus B whole squared, right? So that is 1 minus 2 whole squared star 3, which is equal to negative 1 squared is equal to 1 and then star 3. And so 1 star 3 is again 1 minus 3 whole squared which is equal to negative 2 squared, which is equal to 4. Now 1 star 2 star 3 is equal to basically 1 star. Now 2 star 3 is 2 minus 3 whole squared. 2 minus 3 whole squared is equal to negative 1 squared, which is equal to 1. So that's the same thing as as 1 star negative 1 squared is 1, so 1 star 1, which is the same thing as 1 minus 1 whole squared, which is equal to 0. Right? So that means that, which means that 1 star 2 star 3 is not the same thing as 1 star 2 star 3. Which means that basically star is not associative. Is not associative. So that was this next part of this question. Part 5 of this question is we have star as a binary operation defined on Q, and we have star or A star B is the same thing as A times B divided by 4. Right? Now, in order to show that basically star is commutative, let's do a couple of calculations. Okay, so now basically we know that A star B is equal to A times B divided by 4. And B star A is equal to B times A divided by 4, which is equal to A times B divided by 4. And therefore A star B is equal to B star A. And therefore star is commutative. Star is commutative. Now about star being associative, you know that basically A star B star C is equal to, that is of course for every A and B belonging to the set of rational numbers. Now A star B star C is equal to A times B divided by 4 star C. Now that is the same thing as, so you have the first and the second number multiplied together and then divided by 4. So the first number is 8 times B divided by 4 times C, and then divide that by 4, which gives you basically ABC divided by 16. Now A star B star C is the same thing as A star. Now B star C would be BC divided by 4. Now A star BC divided by 4 is the first and second number multiplied together, which is A times BC divided by 4, which gives you basically ABC divided by 16. And therefore you can see that A star B star C is the same thing as A star B star C, which means that star is associative. Star is associative. So that was question, the part 5 of this question. Of course, here you should say that of course for every A, B, and C belonging to the set of rational numbers, of course. Now part 6 of this question is A star B is equal to A times B squared. Now, and of course, star is a binary operation defined on Q. So in order to check whether star is commutative, you know that A star B is equal to AB squared, and B star A is equal to BA squared, so that they are not the same thing. So in order to show that it's not commutative, we will basically create two examples. So let's say that, for example, 1/2 star 1/3 is the same thing as 1/2 times 1/3 whole squared, which is equal to 1/2 times 1/9, which is equal to 1/18. Now 1/3 star 1/2 is the same thing as 1/3 times 1/2 squared, which is the same thing as 1/3 times 1/4, which is equal to 1/12. And as you can see, 1/2 star 1/3 is not the same thing as 1/3 star 1/2, and therefore star is not commutative. Now, to show that star is not associative, so basically we said that A star B is equal to AB squared. A star B is equal to AB squared, right? So if A star B is equal to AB squared, then, so for example, if I calculate A star B star C, that gives me AB squared star C, which gives me basically the first number times the square of the second number. So the first number is basically AB squared times the square of the second number, which is C squared. Now, if I calculate A star B star C, that gives me A star, and B star C would be BC squared. Now A star BC squared is again the first number times the square of the second number, which is basically B squared C raised to the power 4. You can see that these are not the same things. So now, in order to show that star is not associative, we will create a counter example. So for example, you have 1/2. So let's say that you have 1/2 star 1/3 star 1/3 star 1/4 star 1/4. That's the same thing as over here we said that A star B is equal to AB squared. We said that A star B is equal to AB squared. So if A star B is equal to AB squared, then you have basically 8 times, so 1/2 star 1/3 is the same thing as 1/2 times the square of this, which is 1/9, which is equal to 1/18. So that is 1/18 star 1/4. And again, this is equal to basically the first number times the square of the second number. So that's 1/18 times 1/16, which is equal to 18 times 16 seems to be 288. So what? 1/288. Now if I calculate 1/2 star 1/3 star 1/4, that is the same thing as 1/2 star. Now 1/3 star 1/4 is the same thing as 1/3 times 1/16. 1/3 times 1/16. 3 times 16 is equal to 30, 40, 1/48. That's 1/48. And then this is going to be equal to 1/2 times, this is equal to 1/2 times 1/48 raised to the second power. And what that is basically 48 squared is equal to 48 times 48, 64. 8 times 4 is equal to 32, 38, 0, 32. 4 times that's equal to 32, 3, 16, 19. And you have 4, 0. And you have a 12, 13, 1, and 2, 3, 0, 4. So that is basically 1/2 times 1/2, 3, 0, 4. And 2 times 2, 3, 0, 4 is the same thing as 8, 0, 6, and 4, 4608. 1/4608. And as you can see, 1/2 star 1/3 star 1/4 is not the same thing as 1/2 star 1/3 star 1/4, and therefore star is not associative. Star is not associative. Now question number 10, we have find which of the operations given above has identity. Okay, so we have to, practically we have to solve the question again, right? Okay, so I think the rest of this, the question number 10 is going to take some time. And so I'm going to end this video here, and then we will continue with question 10 in the next video. Thank you.